Phosphate is an important chemical compound containing phosphorus. It has a chemical formula of PO4. Phosphate rock is any rock containing greater than 1% phosphate, and any rock containing about 15% phosphate is considered a phosphorite.
Phosphorus is an essential component of our skeletons, cells, genes, and DNA. Plants require phosphorus as a necessary nutrient for proper growth, along with potassium and nitrogen. Because of this, modern agriculture has come to rely on fertilizers produced from mining phosphate.
Some of the largest phosphate deposits are located in central Florida in a region known as Bone Valley. It's responsible for providing 30% of the world's phosphate and over 2/3 of the phosphate used in the United States. Other states with significant phosphate deposits include Georgia, Idaho, North Carolina, Montana, Tennessee, Wyoming, South Carolina, and Utah. The phosphates we see now are the results of processes that occurred long ago. These deposits formed during the Miocene about 20 million years ago. Sea level was about 100 meters higher than current levels, causing Florida to be covered by a shallow sea inhabited by numerous marine organisms.
A rich, diverse food web was supported by high primary productivity, leading to an abundance of phosphorus in the ecosystem. This moved up the food chain. When these organisms died, their phosphorus-rich skeletons were deposited on the shallow sea floor. This allowed for the accumulation, burial, and mineralization by bacteria to form the immense phosphate deposits we use today. Fluctuating sea levels throughout the Miocene resulted in 3 main events of deposition in Florida, as well as other phosphate-forming events around the world.
Phosphate was first discovered in Florida in the 1880s in Alachua County. It was mined by farmers seeking to take advantage of the 10 billion tons of economic-grade phosphate in the southeastern U.S. It grew to become one of the largest industries in Florida, at its peak employing 15,000.
Today, the industry employs around 6,000 Floridians and is dominated by Mosaic and CF industries. 90% of the phosphate mined is used for fertilizer, while the other 10% is put into livestock feed and other miscellaneous uses.
The mining process begins with the excavation of the 10 to 20 feet of topsoil covering the phosphate ore. This is done by dragline excavators. These huge machines weigh 8 million pounds and have a bucket big enough to hold a car. After excavation, the phosphate is then power washed to remove fines and create a slurry which is sorted by flotation. The phosphate grains then go through the wet chemical process, whereby the phosphate is dissolved in sulfuric acid and reprecipitated into soluble crystals of phosphoric acid. This process produces 5 tons of a waste known as phosphogypsum for every 1 ton of phosphoric acid yielded. This waste is piled into massive PG stacks, which form some of the highest points in Florida.
Increased demand on crop yields from growing populations has led to a significant escalation in phosphate consumption. As a result, our phosphate resources are being depleted at accelerated rates, stripping the land of irreplaceable and invaluable topsoil, destroying the natural ecosystem, and leaving behind immense mountains of phosphogypsum waste that have raised growing environmental concerns for both ecosystem and human health, as they sit, unable to be used for any purpose due to their harmful impacts.
Gypstacks hold wastewater from the mining process as well as spent material from refinement. They notoriously contain concentrated amounts of radioactive isotopes including uranium and its daughter nuclides thorium, radium, radon, and polonium, as well as heavy metals such as chromium, cadmium, and lead.
These chemicals are able to leach out of the gypsum stacks and enter the environment. Sinkholes are common in Florida and can form under gypstacks, causing massive spills of contaminated water into Florida's aquifers and rivers, including in 2016 at a Mosaic mine, releasing hundreds of millions of gallons of contaminated water.
This has resulted in multiple instances of massive fish kills, including the 1997 Alafai River spill, which caused the near instantaneous death of thousands of fish in the Alafai and Peace rivers. Releases of excess amounts of phosphate have also been known to cause algal blooms due to the high amounts of nutrients available. These can be toxic and detrimental to ecosystem health. While mine waste spills are responsible for some algal blooms, they're primarily caused by excess use of fertilizer.
Despite the negative environmental and health effects associated with phosphate mining, the compound and the companies that extract it remain an important and impactful part of Florida industry and economy. Florida's unique geological past created the ideal conditions for a rich ecosystem to develop and provided the state's wealth of this valuable resource. However, poor mining practice and over-reliance on fertilizer are putting the area's phosphate resources and its natural ecology in danger.